Okay, so this one we want to evaluate by changing it up a bit. So we're going to change the top and bottom by timesing by 1, just an interesting type of 1. So if we look at the first one, e to the 2x, sorry. All right, so for example, you might need to play around a bit, but if I times the top by 1 on e to the x and the bottom by 1 on e to the x, I'm really just timesing by 1. Let's have a look at what we get then. So I'm dividing all terms by e to the x. So this just becomes e to the x, and this becomes e to the negative x. All right, if we do it to the bottom, this becomes e to the x. This becomes minus e to the minus x. All right, so let's try that. So if we go 1 to 2 of e to the x plus e to the minus, so you might not get it at first. You might have to play around a little bit. But the more of these you do, the more you'll pick it correctly straight away. You can see that if I differentiate the bottom, I get just e to the x, then the minus comes down, so I get plus e to the negative x, which is at the top. So I've got f dash of x on f of x, so we know it's a log. And it's a log of the bottom, and I'm doing it between 1 and 2. So here we've got log of, let's have a look, we've got e squared minus e to the minus 2 minus log of e to the 1 minus e to the minus 1. All right, now a couple of things you can do there. So I might do to the side. E squared, so it's got powers of negative. So if I change that, so instead of being e squared minus 1 on e squared, which is the first one, I'm going to times everything by e squared and make it e to the 4 minus 1 on e squared. All right, so all I'm doing is timesing through both top and bottom by e squared. And then the second one is, and we know when we do log, using log laws, we're dividing. So we can actually times if we do it upside down. So we're timesing by, so if I times this by e, so that becomes e squared minus 1 on e, did I do that right? Because I did it upside down. E on e squared, yeah, that's correct. E on e squared minus 1. So I'm dividing by that, which means timesing by, so I'm dividing by e squared minus 1 on e, so timesing by e on e squared minus 1. So I've just changed those two, so now I can do the simplify it easy. You see one of these e's cancel. E to the 4 minus 1 is e squared, is difference of 2 squared, e squared minus 1, e squared plus 1. So you can see they also cancel. And what's left is e squared plus 1 over e. So we should get e squared plus 1 over e left. That's all positive. So I can go like that. And I could even just now simplify it to e plus e to the minus 1. So it looks much simpler then. All right, so that's A. All of that is A. Give that a go, see how you go. So let's have a look at B. For B, let's move it over a tad. What should we do? Let's try and multiply by e to the x. So let's have a look. We've got this. If I multiply by e to the x on both top and bottom, I always like just to multiply by something on top and bottom. What does that give us? So let's have a look. We get e to the 2x or ex squared. On the bottom, we get the 2x as well. And here we get plus 1. Now that might be helpful because the derivative of the bottom is close to e to the 2x. We just need a 2 out the front. So what I can do is change that integral, which is like that. So at the moment I've got this, but if I just times that by 2 and put a half out the front, I've now got the derivative of the bottom at the top. So we know that that is log of the bottom, which is already positive, and it's a definite integral. So we're getting log of, we'll do it all at once. So we've got e squared plus 1, e squared plus 1, and we're going to put 0 in, so we get 1 plus 1 is 2. So we get a half log e squared plus 1 over 2. There's your answer. All right, let's look at the third one. So probably this one is the more obvious one. So if we've got 1 on x, we probably want to times by x. So if I just have a look, if I times the top, I'll do it straight away. If I times the top by x and the bottom by x, so I'm going to get a 2x plus 1 on the top and an x squared plus 1 on the bottom. Now that's nice because the derivative of the bottom is 2x, so what I can actually do is just separate them. So let's do the integral of 2x on x squared plus 1 and 1 on x squared plus 1. Alright, we've still got our limits. Alright, so the first one you will hopefully see is that because of the derivative is just a log, and we're doing it between 1 and square root 3. If I do that straight away, square root 3 is squared is 3, so that's log 4. If I put 1 in, I get log 2. So log 4 on 2 is log 2. Hopefully that's okay. You've done lots of those. This one is an inverse tan, so it's straight from your SI table, your reference sheet. If I put root 3 in, I get inverse tan of root 3 is 60 degrees, so pi on 3, and inverse tan of 1 is pi on 4. So I'm getting log 2. I like to do this. I like to say, well, that's the same as 4 minus 3 on, if I change those both to 12. So 4 minus 3 is 1, so I'm going to get pi on 12 there as well. So log 2 plus pi on 12.